I need to make sure that I'm recording from the right channel. That is okay. Yeah, I was just talking about how in the fall there are only 2 sections. I think, is that right? I mean, or are there 3 sections?
Looks like there's 2 sections.
I think if you just look at the numbers, there are only 2 sections.
Yeah, there's only 2 sections. They have it separated by lab and lecture. But if you select one, it automatically selects the lab that corresponds with it.
Also, one class is actually bigger than the other one, right? I think this is the one that is bigger because the lecture time. If the lecture is in room 21, which is this class here, the maximum capacity of this class is only about 40 something. That's the maximum capacity. The other one has its meeting in room 126, which is even smaller. 126 is, I think, right across from here. That's a lab classroom where each student has a computer in front of him or her, and I think the capacity of that classroom is only about 32 or 33. Okay, and that's it. That's a hard limit. This class, section 12216, can only take on about 32, 33 students, no more than that. So, in other words, we have 3 classes, we have 3 sections of cisp300 this semester. All 3 classes will feed into 2 sections of cisp360. That means, on the very first day that you can enroll in classes, go enroll in your classes. Okay, do it as soon as possible. Are there any questions about cisp360? Yep.
Can we take 360 and 310 at the same time?
No, not here.
Yes, one at a time.
Because cisp310 has a prerequisite of cisp360. And it's a very reasonable one, because I changed the curriculum to put in that prerequisite. Because without cisp360 talking about pointers, getting into assembly language programming would be very, very difficult. So that's a really it's a necessary class before you can take assembly language programming. Yep.
So how useful would it be, do you think, to take 370 and then take 360?
370 is considered one of the prerequisites accepted for cisp360, but I think it's a good practice. Okay, after you take this class, you can take cisp370, which you will see a lot of the common topics again. The professor will basically start to talk about variables, conditional statements, loops, and so on and so forth. Except in that class, it does not focus on tracing. So you're not going to trace your programs by hand, line by line, like what we do in this class. In that class, it's more focused on actually getting the program to run inside Visual Basic. Plus, it also has a user interface element to it. In fact, a big portion of that class is how do you use text boxes, buttons, list boxes, radio buttons, check boxes, and whatnot in a form, and you can have programs that are much more interactive than the stuff that we talk about in this class. I think it's good. It's a complementary class to this one. They will also talk about arrays and subroutines, passing by reference, passing by value, local variables, pretty much the same stuff, except it's much more hands-on because you actually have the right programs in that class. So if you cannot get into cisp360, I would definitely recommend giving 370 a try. Is anyone taking 370 right now? No. I sometimes have people who would take 300 and 370 at the same time, and they always come back and tell me how the 2 classes actually interlock, even though there's no real agreement between me and Bob Irvine, who teaches cisp370, and that's a really good thing because we talk about the theory in this class. We do all the tracing by hand in this class. It's kind of boring because you don't really see the program running, and there's no user interface. The other class, does exactly the opposite. They kind of downplay the mechanisms, but they have a lot of hands-on stuff. You actually write programs that have all these user interface elements, and you make programs that are interactive. So I think these 2 classes are kind of good classes to take at the same time, or one after another. Some people take 370 first, and then they take 300, and they find out, oh, so that's what an array really is, because they don't really spend as much time in that class to talk about arrays. Is that okay? Yep.
Is that like Visual Studio kind of thing?
Yeah, it's Visual Basic.
Okay.
Yeah, 370 is Visual Basic. If you look into the schedule or your catalog, CISP 370 is beginning Visual Basic. They cover pretty much the same concepts, except they have a big part on graphical user interface. For anyone who wants to design forms or write programs that are interactive, this is a really good intro class into graphical user interface or programs that are more interactive. Even people who want to do Android programming, eventually, this would be a good class to kind of get a concept, get an idea of what user interface is. How do you write programs that have buttons and list boxes and stuff like that. It's good exposure. And there are only 2 sections too of that class, which used to be 3. So a lot of these classes, we are reducing, from 3 sections down to 2, which means even for this class, I think it's going to be difficult to get into. But there's a lot of lab stuff. If you'd like to see things work, CISP 370 is actually more fun than 360 because in 360, the programs are not nearly as interactive as in 370. So that was a good question. That was a good question. And you can see that in CISP 370, CISP 300 is an advisory, which means it is not a prerequisite. But if you have taken CISP 300 already, taking CISP 370 will be a little bit easier. Okay. Any other questions? Yep.
What's CISP 320?
320 is a class that we have not offered for a long, long time. If I remember correctly, that's probably COBOL programming. A lot of people would laugh and say, "Oh, who wants to program in COBOL anymore?" Well, that's actually not laughable, these days. If you are, getting into the industry right now, which means you're in your, 20s or 30s, and COBOL, you will not have a problem finding a job. Can anyone, guess why that is the case?
They're converting over stuff. They got to convert stuff over.
No, they're not converting. A lot of the old systems that run COBOL, they want to kind of keep it the same way because they don't want to spend the money to port entire systems from COBOL to PHP or Perl or whatever. So they want to maintain those programs that were written in COBOL, but they have to kind of keep up the programs because those programs need to interact with newer systems. So now they need people who can program in COBOL. At one time, we have tons of people who can program in COBOL. What is happening to those people? They're retiring all at the same time. So interestingly, there's a big shortage of COBOL programming these days because we don't teach programming in COBOL anymore in college. Okay, so we don't crank out people who are experienced, in COBOL programming. So if anyone learns how to do COBOL programming on their own and be proficient with it, they would not have any problems finding a job. So that's kind of interesting. Any other questions about the 2 classes that you can move into? One is CISP 360, and the other one is CISP 370. You can try the other colleges too. Does anyone know whether CRC offered one of these classes online? I can just look it up. CRC offers a lot of programming classes online, which is not for everyone. I definitely won't, I cannot take classes online. 360. Yep, this one is online. But I think it's really hard to teach.
The lecture's online, the lab would still be in class.
Yeah, but a lot of times the lab is optional. It depends on the instructor. Most of the time, my labs are optional. Basically it's just a chance for me to help a student debug a program because I can just kind of watch the program and then I can see how it crashes and then I can help debug the program. Otherwise, sometimes it's a little hard to, write in an email, what are the symptoms when the program crashes. So we do have CRC and the other colleges, but you have to keep in mind that not all classes from all colleges articulate the same way. So when you go to assist.org, did I tell you guys about assist.org? in this class, you have to look into the equivalency list or the articulation, because a lot of times you can take a class, let's say CISP430 from CRC. So even though it has the same number and the same title as CISP430 here, the one from CRC may not articulate to the same schools that we do. So that can become a problem, because when it's time for you guys to graduate with your computer science degree and you want to transfer to, let's say, Sac State or UC Davis, they may come back and say, well, we cannot take this class from your, Los Rios, transcript, because this class is not taken at ARC and we only articulate with ARC with that class. So you have to be careful with, that sort of thing when you are mixing and matching classes from different colleges. Any other questions? No other questions? Okay. So sign up your classes as soon as possible. Yep.
I was looking at some of the summer offerings, and Sacramento City offered CISP 360, but it looked like it had different prerequisites. Do you know why that would be?
I do not know. Let me take a quick look here. So that would be a summer class?
Yes.
At Sac City. CISP. Okay, so according to this, they have a CISP 301, which is quote-unquote equivalent to this class. So if you pass this class with a letter grade of C or better, you probably can challenge that prerequisite and take that class also. That's even assuming Professor Dixon is going to check prerequisites. We are all supposed to check, but sometimes some people
I
do.
don't think he does. Because he said, I asked him if I could take 300 and 360. Like, I emailed him and he said it was cool, but I didn't. But I'm glad I didn't. But
Yeah, you can look into that CISP 301, which is about the same thing that we talk about. Main and cache memory. Oh, this is all different. This is completely different from our 300 class. Yeah, so that's not the same thing. But I can tell you most of this stuff is not needed for actually, for CISP 360, because what you need in CISP 360 or to get into CISP 360 is a good understanding of programming concepts, and there's not a whole lot of programming concepts that I can see here in this description.
Is there a math prerequisite for 360?
For P360?
Mm-hmm.
No. If you read this part, it only has a CISP 301, and 301 in this case has an advisory of 310 and at least 1 year of high school algebra or math 100, which I think most people should be able to have.
No, I meant for 360 year.
No, we don't have any math prerequisite. It's just P300, just this
So
class.
taking that program shouldn't be a problem?
Nope, should not be a problem. You mean getting into this class?
Yes.
Yeah, that should not be a problem. Okay. Any other questions? But a summer class is always very intensive, so you guys need to make sure that you can handle the intensity of a summer class, especially when it's a 4-unit summer class. If you look at the schedule, the lecture and the lab combined is going from 5:30 to 9:30 basically. Yep, 4 hours. and it's 4 hours on 2 days, in a week. So that's a lot of time. You have to make sure that you can have enough time not only to go to the class and also the lab, but also to study before that, and also study a little bit after that too. So that's that. And this one, it does say it is transferable to UC and CSU, so that's good. But when it says it's transferable, it does not always imply it articulates with the equivalent class at those schools. So it's a different thing. Any other questions? No questions? Okay. If there are no questions, I'm going to leave this page open just in case people have questions about that. I finished grading exam 2. For the first question, I was really, really detailed. I list out all the points, but I found out that doing that is taking a lot of time, so I didn't do it with questions 2, 3, or 4. Or at least my questions 2, 3, and 4. I will disclose the marking scheme later on. So that you guys know why you get the point values that you're getting. but it will be in a slightly different way. Okay. Are there any questions about exam 2?
How did the overall class do?
Overall speaking, the class did okay, I would say. I saw 2 peaks. The histogram looks kind of interesting. The histogram looks kind of like, if you look at, 0 here and 20 points is the full score over here. I see a histogram that's kind of like this. Okay, so we have a little peak here, and then another peak here, and then it kind of stays flat there. So this peak, peaks at about 10 points, which is a C in this class, and this peak is actually at 20 points. So a whole bunch of people got A's, and then there's not a whole lot of people getting B's, but a whole bunch of people got C's, and that's that's the distribution of this class. Any other questions? 3 people got 100 out of 100. I was kind of surprised, pleasantly surprised. Okay. Any other questions about exam 2? We talked about the solutions already, so this is one that we have already covered. I just wanted to kind of give you guys an idea of the curve. Have you guys looked at your grade book? Some of you have, right? Your ranking in the class is in the grade book as well. In other words, it will show, okay, if you are the best student in the class, you will see 1/34, which means you are the first of 34 students. Okay, the person who got the lowest score will see 34/34, which means rank 34 out of 34 students. I do not use this for grading purposes, but it is kind of useful from your perspective, so that not only do you know your score, you also know, relatively speaking, where do you place within your peers. Okay, if you're scoring kind of low, you might want to kind of figure out why your score is a little bit low. Sometimes, if I have a really good class, it is possible that 34 out of 34 is also somewhere around here. That's possible, but not in this case, not in this class for this exam. Okay. Any other questions? No questions? Any questions about the concepts that we have covered so far in this class? Do you guys want me to go over any particular concepts? No? So we are moving on with object-oriented programming. Okay, we can do that. It's just that I want to make sure that you guys don't have any questions about especially concepts in exam 2. Okay, these stuff you cannot really see because it's all grayed out. It's hidden from you. Last time we actually talked about inheritance and extension. Okay, so I'll just kind of go back and talk about that a little bit. And what we can do is to pull out the notes from the other day. Which I have forgot. I have not uploaded yet. Okay, so this is the program that we talked about the other day. And instead of using the word record, I switched to the word class. Now that is a kind of minor thing to do when it comes to syntax, but it does make one thing possible. It makes this possible. I can define what we call a base class, or this is also called a superclass, and it is called a shape. Okay, and for the time being, you can just see a class as a record. It has basically the same concept. A class called shape has 3 members at this point. It has a member called color, transparency, and rotation. Now, this is nothing new. Okay, it is the same thing that you can do with records. But what is on line 16 is something that we have not seen before when we talked about records. Because on line 16, it does not just say that we are defining a new class called pixel. It is also saying that a pixel is a shape. Now, what that means is, by this implication, a pixel also has a color, it also has transparency, and it also has rotation. All the members that are in shape are automatically in pixel as well. They do not need to be spelled out again. Yep.
So are we going to be using the term record anymore in this class?
When we use concepts like this, which is called inheritance, we do not use the word record anymore, and then we switch to the word class. But a class, in terms of derivation, it comes from the concept of a record or a struct in C. It's just an extension of the concept, but because of the extension, we don't call it a record anymore. Now we call it a class. And a class is a class regardless of the programming language. In other words, certain terms in object-oriented programming are universal across almost all programming languages. You have classes in PHP, you have classes in Visual Basic, you have classes in C++, you have classes in Java. So most modern programming languages that are capable of object-oriented programming would refer to the same thing as a class. But it really is a super-duper version of a record. It is still a cookie cutter, except the cookie cutter now takes on special abilities like inheritance in this case. Do we have any questions at this point about the differences between a class and a record? It's an extension. It's just an extension. Now, I also defined the stub subroutine here. The stub subroutine is not done, but the intention is not really to do that part. The intention is to show you what I can do on line 25. Because on line 25, let's see what we are doing on line 25. Line 25, let me move the mouse pointer because it's right on the dot. Okay, there we go. Lowercase circle is the name of a local variable because it's right here. Uppercase circle is the name of a class. That's also a convention that is observed by programmers of all different programming languages. If you start a name with an uppercase letter, it is implied that it is the name of a cookie cutter. If you start a name with a lowercase letter, it is implied that it is a variable, an object. So in this case, we have lowercase circle being a local variable of the type of the class circle, uppercase circle. When you look at the definition of the class circle, it has a center, it has a radius. But how come I can on line 25 say that the transparency of this circle getting 0? It is because, go ahead.
I was just going to say circle is a shape, so you go back to shape.
Exactly. So a circle is a shape, and because a shape has a transparency as a member, now anything that is a circle also automatically has a transparency member. So that's inheritance. That is inheritance. Which is about the same thing as inheritance in the animal kingdom. When you say a fly is an insect, you don't have to say that a fly has 6 legs anymore because all insects have 6 legs. You don't have to say flies have 2 antennae because all insects have 2 antennae, and so on and so forth. So this is a very good way of organizing members of these items. Do we have any questions at this point about the definition of classes and how we can use classes, members of classes at this point? No questions? Okay. If there are no questions, let me save this in today's folder because we're going to do something else with this. Now, what we are talking about now, is definitely a little bit beyond the scope of this class, and possibly even beyond the scope of cisp360. But if you are on a programming track, you will eventually encounter these concepts again. So they're useful concepts to understand. All right. So the first thing I want to illustrate is, let's pick. We have a pixel, we have a circle. Let's see, we have, I'm trying to make more specializations here. Well, rectangle is a specialization. Well, what is a specialization of a rectangle? A parallelogram. But I'm trying to see how I can express that.
Square.
A square. A square is a special rectangle. That's right. And ellipse and circles, they are also related.
Can you do triangle? Full circle is circles.
I can do triangles. let's just talk about a rectangle first. Okay, so a rectangle is a shape. And last time we talked about how to represent a rectangle, because a rectangle has 2 points. So we can say corner 1 is a coordinate, COORD, and corner 2 is also a coordinate. Class, and so on and so forth. So now we can have a lot of these different definitions. Okay. Now the question now is, if I want to write subroutines to draw the shapes on the screen, how am I going to do it? The old way of doing things is to write subroutines, define sub that is outside of the class definition, and let me just illustrate the old way of doing things. The old way of doing things is like saying define sub. We can say draw pixel, and it will definitely need a either by ref or by val. Either way is fine, but it needs a parameter to specify the pixel that we are trying to draw, and then we specify the logic to draw a pixel and define sub. And I call this the old way of doing things, because if I do things this way, don't I need another one for draw rectangle? Don't I need another one for draw circle, draw line, and so on and so forth? And I will end up with a whole bunch of subroutines, which is there's nothing wrong with that. Okay, there's nothing wrong with that, except it is very tedious, and it is also very tedious every single time you invoke the subroutine draw pixel. You have to pass a parameter which is a pixel, which is kind of obvious, right? I mean, draw pixel should only work on pixels, but yet you have to supply which pixel am I drawing on the screen. Okay. So the new way of doing things is a little bit different. It is kind of like this. You go to the class definition, and then you go like this. Okay, let me give it a few more lines here. Inside the class definition, you say define sub draw. Not draw pixel, just draw. Okay. Then you specify the logic to draw the pixel and define sub. This is something that we haven't seen before either, because originally we thought that we can only have members that are integers of other types, but now with object-oriented programming, not only can you inherit properties or members from a superclass, you can also specify operations inside the definition of a class, which you cannot do with a record. Okay. So let's see, what is the difference between these two approaches. I mean, if we do something like this, how do we invoke the draw method? And you can see that this draw does not have any parameters. Okay, it does not contain any parameters. But instead of using draw, let me just give you a different example. We'll do an initialization. If I want to initialize a pixel, P is a pixel, and we want to specify, well, let's just say that when we initialize a pixel, we just want everything to be zeros. Okay. So in here, the way we specify that logic would be something like this. P dot, okay, what does the pixel have? A pixel has a C as a coordinate, okay, P dot C, and a coordinate has an X, that gets 0, P dot C dot Y gets a 0, and defines up. Let's just say that these are the only two things we want to initialize inside the pixel. Okay, so right now I'm already doing something that I'm not supposed to do. Why do you think I'm doing something that I'm not supposed to do? Okay, now this subroutine, which has the name of init pixel, obviously it should have access to the members of pixel. But I'm not only using members of pixel, which is p.c, I'm also directly accessing members of the C, which is a coordinate. I should not be doing that. Okay, but just for this example, I'm doing it because I want to illustrate another point. But I do want to point out that I'm not supposed to use, I'm not supposed to look into a coordinate directly inside something that should only be looking into a pixel. Okay. Now, if I want to do the same thing inside a class, I would do it a little bit differently. Let's see, insert row 1, 1, 2. That should be good. Okay. So I would say define sub init instead of init pixel. And what I would do is to say right away, I can say c.x gets 0, c.y gets 0, and define sub. Let me fix the indentation, then we'll answer that question, which is kind of a very obvious question. Okay, let's go to the one that we are the traditional way of doing things first. Is that okay? I mean, do you guys understand this one? It's a regular subroutine. We have a parameter passed by reference. The parameter name is p, lowercase p. It is of the type pixel, which we defined earlier as a class. Well, a pixel has a member called c, which is the coordinate. A coordinate has a member called x, which is an integer. I can now initialize that to 0. I can do the same thing to member y, because that's also an integer. I can also initialize that to 0. So there's nothing wrong with this subroutine from that perspective. It is wrong from the perspective of abstract data type, because I'm accessing a coordinate directly. Okay, so are there any questions about line 38 to line 42? No questions? Okay. Now we go back to this part here, line 18 to line 21. That's mysterious, right? I mean, whose coordinate are we talking about? Whose lowercase c member are we talking about? And by the way, how do we invoke this subroutine? How do we know that we want to invoke the init of pixel? Because guess what? I can do about the same thing with circle. Okay? And let me just show you this part here. Insert. For the circle, I have a few more things to initialize, so I'm going to leave more lines here. Define sub, guess what? I can use the name init again. Okay? And in here, I can say center dot x gets a value of 0, center dot y gets a value of 0, and let's say r gets a value of 0, and define sub. Yep.
How can you have two subroutines with the same name and same program? How do you know which one to access?
Exactly. That's a very good question. Okay. So let's take a look at how we can use variables of the pixel type and variables of the circle type. Okay, and how we invoke the subroutine that we call init. Okay, because they are exactly the same name. If you look at this subroutine and look at this subroutine here, they have exactly the same name. So how can we resolve, which one are we actually using when we invoke it? And how do we invoke something like that? Awesome. Okay, so let's go ahead and have our subroutine back. Define stub. And in this particular stub subroutine, we have a local variable p, which is a pixel. And then we have a local variable circle, lowercase circle, which is a circle. Okay. So this part is not too mysterious. It's not too bad. It is the next step that will seem a little bit interesting. This is how we initialize the pixel p. This is how we initialize the init of circle. That's object-oriented programming.
So
Okay.
the subroutine has actually become almost its own child of the class that you put it in?
It becomes a part of it becomes quote unquote a part of the variable, just like the coordinate c is a part of p. The subroutine also becomes a part of it. Okay. So when I say invoke p.init, do we know which init is actually getting called? How do we know? it's implied by the type of P, right? Because P is of the type pixel. So when we say, oh, go ahead and do the init subroutine of P, because we know P is a pixel, we automatically know that we are supposed to go into the class pixel and pick up the init subroutine from that class. Is that okay? Kind of? Now, on the next line, on line 52, we say invoke circle.init, which means we are invoking circles apostrophe s init. Remember the dot means apostrophe s? Okay, so when we say circles init, which one are we talking about? Well, it depends on what type circle is. Circle is of the type circle with the uppercase C. So that's how we know that this init is the init that is defined in class circle. And this is called object-oriented programming because everything is seen from the perspective of what? The objects. Or we don't use the word objects in this class in cisp300. We simply use the word variable in this class. Okay? A variable is a special case of an object. There are other objects that have no names. Variables always have a name. Are we doing okay with this? Yep.
So it looks like this would be a good substitute for passing something by reference in
Exactly.
like a normal subroutine.
Yep.
But what happens if you wanted to pass something by value, because that would have a different effect?
Sure, you can do that. You can still, the subroutine that we define can still take parameters, and you will still pass parameters the same way as before. So that part is not a problem. We can still do the same thing as we do. It's just that it is implied that you have one parameter already, which is the other thing that I have not illustrated. Okay, when you look into the subroutine, let's say this part here. Let's look at line 30 to be more specific. Line 30 is saying center.x gets 0. It has no parameters. So whose center are we talking about? What do you think?
Circle.
Okay, the circle's center, right? But which circle are we talking about? This is a class definition. In other words, this is a cookie cutter definition. So when you look at this, you have no idea whose center we are talking about, but when you invoke it, you know exactly who we are talking about. Because line 30 links to line 52. When the program executes line 52, it is invoking circles in it. So whose center do you think we are accessing, we're initializing to 0?
The circle that's invoked.
Lowercase circles. So that's why it is called object-oriented programming, because everything is seen from the perspective of the object. The lowercase circle is the object. Is that okay? I mean, it's really doing the same thing as what we have done before, but we're changing our perspective. Instead of looking at it from the perspective of variables and subroutines and stuff like that, we're now looking from the perspective of the object, the variables themselves. Yep.
So you could have different circles?
Oh yeah, definitely.
Like you have circle 1, circle 2, local.
Absolutely. Let me show you what happens when we do that. Okay, so let's say we have another circle. We'll just call the other one C2. So we change this one to C1.
Shouldn't circle be capitalized on line 51?
Oh yeah, definitely. And then we have invoke C2.init. So now what we have is C1 on line 53, it will go ahead and initialize the center of C1, but on line 52, it will initialize the center of C2. Is that doing okay so far? In other words, when you are looking at the subroutine inside the class definition, I'll just point out line 30 and line 31 here. When you look at these two lines, the center is the member of whichever object is starting the invocation. Because we are saying C1.init, we're invoking C1.init, then this is automatically the center of C1. Yep.
So does that mean that every circle that's an object is going to get initialized to the same center point then?
Yes, they are.
By definition?
According to this logic, they are.
Yeah, according to the logic, yes, the pixel and both circles, which also have a radius of 0, basically you're putting 3 points on top of each other.
When they are first initialized,
Right.
But you can change that later if I define additional subroutines. Then you can change the center, you can change the radius, and so on and so forth. Yep.
It seems as though this would, it's not necessarily, I don't know, why it'd be advantage, because it looks like you're putting more lines as opposed to putting fewer lines. Or maybe I'm not looking at it.
Well, there are a few advantages. Okay, there are a few advantages. If we did not do it like this, then we'll end up with multiple subroutines. One is called init pixel, one is called init circle, one is called init rectangle, and so on and so forth, right? This will declutter the namespace because now there's only one subroutine called init, because init is defined inside the class. So so the so-called init pixel becomes subroutine init in class pixel. The so-called init circle becomes subroutine init in class circle. So you don't have to invent as many names as you normally would have to, because you can use the same name inside the class. Is that making sense so far?
Also,
Okay.
if you look at the point, like he just started to show us, we did 2 circles, but he only had to invoke the init because it's already in the class. Say we were going to put, 8 circles, then it's less code. The more objects you're actually going to create that are similar, it's already there in the class. You don't have to keep redoing.
Yep. Well, there's also one more advantage too. If let's say down the line here somewhere, you know that a particular variable is a shape. You don't even have to remember what kind of a shape it is, because if you know that all shapes have an initialization subroutine called init, or has a draw logic in a draw subroutine, you can just say s1 whatever the shape is dot draw, and that will draw the thing on the screen, and you don't need to remember what it is, as long as you know it is a shape. Is that making any sense? Kind of? Okay. Yep.
Well, like what I was asking earlier is that because I asked about the by reference thing, it was because in this subroutine you defined it as a local variable and not as a by reference, but just by the nature of that's the thing that's being modified by the class, it acts as a by reference.
Yes.
So if you wanted to pass something by value and have it alter a copy of the variable or the value of the variable, how would you do that? Because
well,
wouldn't it be
okay.
working?
I understand your question. Okay, then you have to ask the question, what the logic that you're trying to define, is it an operation that is inherent to a circle? That's basically that's the question that you have to answer. Because we are looking from the perspective of a circle. So the question is, is the operation that you want to specify that requires to pass a circle by value, is that a native operation of a circle? A circle can draw itself on screen. A circle can initialize itself. A circle can do all these things. But all of those operations require that the circle itself be passed by reference, because you can potentially change properties or members of the circle. If you pass something by value, that implies that you don't want to change any data that is inside the object itself.
Well, I'm not thinking about the circle specifically, but I'm just thinking that there are going to be times when it's desirable. Yes. So.
Yep, and you can still do things the old way. Even with object-oriented programming, you can still define quote-unquote pure subroutines where everything is passed by parameter. So you can still do things the same way as before, but on top of that, you now have a new way of organizing your code. Yep.
So when we have the subroutine inside the class, is that kind of like that'll declare our code because every time we want to initialize like a circle, all the code to do that is already in the class in the form of the subroutine, or
Kind of. It's kind of. One thing I did not talk about here is the constructor method or the constructor subroutine, and the destructor subroutine, which is kind of way out of the scope of this class. So that's why I'm not going to talk about the constructor and the destructor. But what you were asking, is the jobs of a constructor and a destructor in the class. In other words, when you do something like this, let's say on line 50, when you say that I need a local variable C1, which is of a type circle, you can associate this with a quote-unquote hidden subroutine in circle, so it will do all the initializations automatically. You don't even need to say invoke C1.init. It can be done automatically. But we are not going to talk about it in this class because it is a little bit beyond the scope, and it's really just kind of adds to confusion. But what we are talking about is the fact that you can have init in a pixel and also an init in a circle. And the notation has changed. Instead of passing C1, C2, and P as a parameter, now we are reversing the roles and say, let's start with local variable P, C1, or C2, and say that, C1 as a variable, go ahead and do your init thing. Instead of saying, init circle, but what am I initializing? You're initializing C1. So it's a change of perspective in this case. Yep.
So even though you can make as many circles as you want, they would all start out, you could have them all start out at a certain point.
Mm-hmm.
But to change all of them, you would need to change one individual one, you would have a separate change in the class?
Correct. You can also do something like this, which is not recommended. You can always say, inside, depending on the programming language and how you set it up, you can still do something like this. You can say C1's center.x gets, 652. You can do that. You can still do that. Okay? Because remember, a class it can do everything a record can and then some more. So we can still do something like this, which is not recommended because you're looking into the definition of a circle directly when you specify code like that. Okay. Any other questions about object-oriented programming at this point? No questions? Okay. So what we have talked about so far, let me just identify those concepts at this point. Okay. First of all, if you look at line 1 to line 4, okay, let me highlight those 4 lines. When you look at line 1 to line 4, a class is basically a record. Okay, it can do everything that a record can, except it can do some more stuff. The some more stuff, starts with this part here. Okay, first of all, if you look at line 16, a class has the additional ability to be associated with another class. In this case, a pixel is also a shape, which means everything that a shape has and can do, a pixel can now do that as well. If you have a subroutine that is defined inside shape, guess what? That subroutine is now accessible by a pixel as well. Okay? Are there any questions? Yep.
Can you say that one more time? What do you mean it's accessible by the
Let me just change the code and give you an exact example. So let's say a shape is a class, right? And we have just talked about how you can define a subroutine inside a class. So let's go ahead and do that. Okay, so we'll insert a few rows here and say define sub make transparent. So to make something transparent, you turn the transparency, you crank it all the way up to 100%. So that becomes completely transparent. And define sub. Okay, so let me fix the indentation first, and then I can illustrate what I mean by this. Okay. So I have just changed the program a little bit. I inserted a subroutine called make transparent inside shape. I did not make any shapes, inside my program. There are no local variable of the type shape, but I do have, things that are made out of pixels. A pixel is a shape. So in this case, a pixel does not only inherit color, transparency, and rotation, it also inherits make transparent as a subroutine. So that means inside my stub subroutine, over here, I can now say, invoke, C dot make transparent. Is that working out so far?
Yeah.
Because everything a shape can do, now pixels and circles and rectangles, anything that is also a shape can do these things as well. It's just like in the animal kingdom, fish is an animal, okay, and a shark is a fish. But because a fish can swim, a shark can automatically swim because it is a fish. It's exactly the same way here. So this is a really kind of powerful way of organizing things, because if you define a class that is very general, just like insect is a very general quote unquote class in the animal kingdom, then everything that you list under that class also automatically inherit all those traits, properties, as well as abilities. Okay, is that working out so far? Yep.
So you could also make, like, you can have your subclasses can be superclasses and other classes too.
Yes, the hierarchy can keep going. Just like you have the insect class, then you have flying insect class, then you have fly inside the flying insect class, then you can have fruit flies inside the fly class, and so on. You can go as deep as you want. It's just it makes organization a whole lot easier this way. Yep, and it's a very powerful way of organizing your code, because it's not really just organizing the members, it is also helping you to organize the subroutines, the code that goes along with the data. Okay. Any questions at this point? No questions? Okay. Now we'll go ahead and do something that's even more interesting. But before we do that, in code, we'll talk about it in using an analogy first. The technical name of that is a virtual member function, okay, which is kind of like a really, really bad name for that. So let's just say that forget about coding for the time being, and just think that you are a stage manager. Okay, you're responsible for a show, and you're responsible to tell people to get on stage, do whatever they need to do, get people off the stage, and so on and so forth. Okay, and let's just say that this is a talent show, and with a talent show you have people of all sorts of performers, right? But they're all performers because they have something to perform on stage in order to compete in a talent show. Okay, so let's think about it this way, and we'll do it. Well, guess what? We'll do it inside the code here, and we'll use another sheet for this. Okay. So what we'll do is we'll first define a class called performer. Okay. And the class performer probably has all the common members that are related to performers. What do you think are related to a performer, regardless of what they're going to perform? The name. They're all people, right? So they all have personal identifications. So just for this example, we'll start with performer as our superclass. So you can have name, which is a string. A string is basically just text stuff. You can have address, which is also a string, and so on. Okay, so there are a lot of stuff that are common to all performers, regardless of whether they are singing, they're dancing, or whatnot. In terms of operations, what do you think is common to all performers?
Going to work.
Going to work or perform, right? Okay, so we'll go ahead and say, all performers, need to know how to perform. Except there's a problem here. I cannot specify exactly the logic or the procedure to perform, because I'm not talking, at this point, I do not know whether I'm dealing with a singer or a dancer or, what else?
Whatever.
Comedian, okay, and so on and so forth. So I cannot really specify the logic of, how to perform, but I know that if you have a performer, that has to be a way to perform. So what I'm going to do is, instead of using a define sub, perform here, I would just use, the English equivalents, like, need to perform, okay, or knows how to perform, and that's how I would just leave that. Okay, so as a superclass, performer is a very special kind of superclass because it does not say exactly how to perform. It just knows that if an object is a performer, it needs to know how to perform. Okay, so we'll leave it as this, at this point. Then we have singers. Okay, well, guess what? A singer is a performer, right? So right here, I don't have to replicate name and address and all the other stuff that are predefined in a performer. But what I do need to know is to say define sub perform and then specify the logic to sing. I'll fix the indentations. Okay. In other words, because the class singer is a subclass of performer, and I know that anything that is a performer needs to know how to perform, but I know enough details now to specify the logic of how to sing, how to perform. Is that okay so far? In other words, I know how to implement perform once I know what kind of performer we're dealing with. We can have another one. We can have a dancer is a performer. And here I can also define the same thing. I can define the subroutine called perform, specify the logic to dance, and define sub and class. So obviously this subroutine will be different from the other subroutine because the way a dancer dances is definitely different from the way that a singer sings. Okay? Is that okay so far? Yep. Question? No? Okay. So since this is a programming class, we have to definitely include a geek. But if you look up the word geek in a dictionary, it's not quite a techno geek that we come to know these days. Has anyone looked up the dictionary, and looked up the word geek? No? What do geeks do in a show, in a performance? They bite the heads off chickens. Circus show, basically freak show. That's the original that's the original definition of the word geek. You guys don't believe me, do you?
I'm looking at it now. There's 3 different ones.
That's a rap.
Hmm?
Isn't that a rapper? Look at the first definition.
Look at the third one. A carnival performer who performs sensationally morbid or disgusting acts as biting off the head of a live chicken. Yeah.
Ozzy Osbourne, hit the head off a bird of the show.
I think that's a pretty hard thing to do, if you ask me.
The thing is, how did that convert into becoming a slang for somebody who's intellectual or
Enthusiast.
I'm thinking, having eaten all that chicken brain, makes a person more intellectual. So it's a little kind of, it's an evolutionary kind of thing. You kind of go from here to here, and then from here to here.
we all thought you absorbed the power of the
Chicken.
thing.
Wow.
Humans used to eat eyeballs and people they respected in power because they thought they would absorb their strength.
Mhm.
But people are weird. Yeah.
Okay. Chicken, yes. It's interesting how the meaning of words have changed their meanings over time. Has anyone read Wizard of Oz? The Wizard of Oz and the Wonderful Land of Oz and stuff like that. If you read that book or read that novel, when they talk about queer, has a different meaning than the word queer that we use today. It really does. I mean, they use words. The old usage of those words are completely different of of the meaning of those words today. And this is geek is also an example of that. Okay, so now we have defined 3 different specific performers, and with each specific performer, we have all these terms. Okay. Okay, so now remember, you are a stage manager, right? You have a long line of people who are waiting to get on stage, get their 10 minutes of fame, to compete in a talent show. Okay, so when you take these people, one by one, do you ask that person and say, are you a singer, are you a dancer, or are you a geek? And then depending on the answer, then you tell that person, oh, go ahead, and it is now your turn to sing, or go ahead, it is now your turn to dance, or this is now your turn to bite the head off of a live chicken. Do you have to do that? No, but instead, what do?
Go perform.
You just tell them to perform because every performer knows how to perform. You don't even need to know what kind of performer they are. You just grab the next person when the stage is all set up. You just say, okay, it's now your turn to perform for 10 minutes. We want to be able to do the same thing with programming. In other words, we want to be able to grab an object that is definitely a subclass of a performer. We don't know exactly which subclass it is, but we know it is a performer, and then just tell that object, go ahead and perform. So let's see if we can demonstrate that particular example here using our little stub subroutine. So in this case, in our stub subroutine, let's say we have a local array. Okay, so our local array is called performers. Okay, and we're basically representing the objects that can perform. But instead of making this an array of singers, an array of dancers, or an array of geeks, I will make this an array of, say, 3 performer. Now you can see that performer is in uppercase. It is matching the class name performer here. Is that okay so far? Now I will do something that you would think, but are we sure we can do something like this? Okay, so we'll say local, name one famous singer. Don't say Lady Gaga. Because I said that not because I have any personal grudge against Lady Gaga, but because she can fall into either category. Okay. Barbara Streisand, but that's too long to spell.
Robert Plant.
Madonna.
Pet Shop Boys. Yeah, Pet Shop Boys are not really exactly Pet Shop Boys anymore. They're Pet Shop Old Men now. Have you seen the Pet Shop Boys lately? No, they're kind of old now, but they're still doing stuff. That's the amazing part is they're still doing music. Okay, which one?
Madonna.
Madonna. Okay, so Madonna is a singer. She kind of crosses over to dancing too. So who would be a good dancer?
Fred Astaire. Fred Astaire. Fred Astaire.
Fred Astaire?
Way back in the day.
Oh, way back in the day, there are multiple
He
ones.
was comparable to Gene Kelly. They were the 2 top dancers.
Michael Jackson's actually a good dancer.
Michael Jackson?
Yes.
Yeah, okay. We'll do Michael Jackson.
But he's also. Yeah, that's actually.
Okay, who's a famous geek?
Ozzy Osbourne.
Okay, well, Bill Gates, officially is actually not a geek. Bill Gates, the best word to describe Bill Gates is he's not a geek. He's more of a strategist than anything else. That's his contribution to Microsoft is acting as a strategist, but not as a geek. Paul Allen is more of a geek. I mean, he's more on the technical side, just like Steve Wozniak is the geek of Apple, but Steve Jobs is not the geek. He's the innovator. But they're all pirates.
Yeah.
They're all pirates in suits. Yes. All right. Well, so now we can do something that you think, but are we really sure we can do that? Okay, because now we say performers bracket 0. Can we do this? Can we say performers open bracket 0? Yeah. Because performers is an array. and I can do indexing with arrays. Okay, so we definitely can do something like this. The next one is the one that has a big question mark. Can we do something like this? Can we say Madonna as a local variable? Can we make this assignment happen? What is one of the requirements of assignments? Can I?
Their type has to match.
Their types have to match. Very good. But in this case, the types do not match, because performers is an array of performer, and Madonna is a singer. But every single object-oriented programming language will let you do this.
Because the singer is also a performer.
Exactly, because a performer is a superclass of a singer. Okay, so the assignment can occur as long as the right-hand side is a specialization of the left-hand side. The left-hand side is a performer. The right-hand side is a singer. A singer is a specialization of a performer. So that can happen. Yep.
Like in this example, the main difference is that the subroutine is different, or the logic in the subroutine, but there's no additional like fields for the record, or no additional like
Members.
data types.
Mm-hmm.
So if it was the case that
Well,
there were additional data types, would it just transfer in the ones that were present in the superclass?
I cannot explain the quote-unquote magic that happens behind this, but it is an entirely different thing. You know, it's really hard to represent using columns that we do in this class, you know, to explain, you know, what's happening when we do something like this. It's basically preserving everything in Madonna, except only the parts that are common to performer is exposed. So once you perform this assignment statement, performer bracket 0 can only be seen as a performer and cannot be seen as a singer anymore. So anything that is specific to a singer is no longer accessible as a performer bracket 0. Yep.
So what's the bracket 0 for again?
It's an array indexing thing. Because performance is an array, I just make the first element Madonna. Yep.
Wouldn't you need like a dot name or something like that? So that no?
No, because Madonna is a local variable, and performers is an array of 3 performers. So you know the assignment operator works just fine.
But even with the capital performer has 2 different parts. So
But as long as the types of both sides match, an assignment can happen. It's not comparing. You're thinking about comparison. With comparison, yes, you have to get down to things or types that actually can be compared. But when you're talking about assignment, you can have assignments of 2 big, huge, you know, records. As long as they are of the same type, of the same record type, the assignment can happen. It's just making a copy of one to the other. So we'll go ahead and finish the initializations here. Okay, performers 1 is Michael Jackson, and performers 2 is Bill Gates. Okay, so now we have an array of 3 performers. And as a stage manager, this is now what I need to do. I need a local variable I to go through the entire array. This part is fairly simple, and you have seen this many, many times over. So I would initialize I to 0, while I is less than bar performers bar. Basically, I go through the entire array one by one. And what I do is I just say invoke performers bracket I dot perform. I gets I plus 1 and while. And define sub. So I'll fix all the indentations, and then we'll come back and look at that loop, because that loop is interesting. It's doing something that we thought, hey, but how can that happen? Okay. So let's take a look. Let's focus on these 6 lines. 8 lines here. Okay, lines 28, 29, and 30. They are assignment statements. You know, basically what they do is to say Madonna becomes the first performer, Michael Jackson becomes the second, and Bill Gates becomes the third. But in the process of this, performers bracket 0, bracket 1, and bracket 2 can only be seen as performers. You can no longer see anything that are specific to singers, dancers, and geek. Okay? From line 31 to line 35 is a loop, basically. The loop just goes through every single element in the array. So in other words, if you look at line 31, line 32, line 34, and line 35, there's nothing mysterious about those 4 lines because those are the common logic that we have used many, many times to go through elements of the entire array. So the only line that is interesting is line 33. So let's go ahead and just focus on line 33 at this point. Line 33 is interesting because all it is doing is to say, okay, let's take a look at this, component by component. Performers is an array of 3 performers. But since it is an array, we can do indexing. So we use square bracket I, close square bracket, to access a particular performer in the array. Well, any element in that array is a performer. And the performer can perform. It is one of the things that a performer should know how to do. So that's why there's no problem here. The question is, when we go to, when I is 0, does that performer know exactly how to perform in order to sing? Because that's Madonna. When I becomes 1, does that know how to dance? And when we get to the third one, does that know how to bite the head off of a live chicken? The answer is yes. Okay, so this is the other interesting part of object-oriented programming is you can specify something like our performer here on line 5. All you say when you specify the superclass is to say that a performer needs to know how to perform. But it's a placeholder. It does not say how to implement it. It does not say exactly how to perform. It's a placeholder to say that all performers need to know how to perform, but I'm not going to specify that here. Instead, what you do is later on, when you define subclasses of performer, then you can specify, you can implement the perform method or subroutine. Okay? And that information is quote unquote sticky. It is sticky in a way that Madonna knows how to sing, and when we perform the assignment to performers bracket 0, the sing logic of perform of a singer becomes quote unquote sticky. Okay? It is now attached to the first element of the array of performers bracket 0. Yep.
So on line 33, when it says invoke performers isn't actually a subroutine, so how do we...
The performers is not. Performers is an array, but it is an array of the type performer, right? So performers bracket I becomes a performer object, right? But what can a performer object do? Well, we have to go back to the class. A performer knows how to perform. And that's why we can invoke it.
So we're accessing a subroutine that's in the class
that's being called.
So, so the placeholder lets the array know that it needs to keep that place, and that access
Exactly.
is what allows it to be sticky.
Yep. Yep. And this is really interesting because it allows us to do what we just specified in the stub subroutine. Okay, and that's that's one big part of object-oriented programming is abstraction. Okay, because performer, if you look at this class here, the performer class, that's an abstraction of all objects that knows how to perform. And you can use this, so that you can unify all the different types of performer. When you don't need to know exactly how to perform, what is the score, what are the dance steps, and all the specifics of the performance, you can just call everything a performer and just say, go perform. Yep.
So if I'm a machine, I invoke the object, right? And that takes me back to the original class, right? And say, he knows how to perform, and then I go to the next subroutine that's for the specific type of performer, and then it tells how to sing.
In the case of the first element in the array, it will first hit this part here, but there's a quote-unquote sticky thing about it that makes it know how to get back all the way down here. because Madonna was originally a singer. So when we abstracted Madonna into a performer, that part becomes sticky. How to sing becomes sticky. So when it gets back here, it actually knows how to get back down to the logic to sing. And it's really hard to illustrate it, as much as I want to explain the actual mechanism of how this can happen. It is way too complicated to explain it in this class. But so instead of explaining the mechanism, I just want to explain, how you can use that feature in this class. This is material that you will see in cisp300. This is cisp300 material, but in terms of concept, it is not as complicated as the actual implementation. Okay. Any questions about this stuff? Now, once again, none of this will be in the final exam. It is really all extra stuff. But I think, the earlier you guys get an exposure of this, the better, because the next time you see this again, hopefully it will click in a little bit quicker. All right. Yep. Question?
So if I was actually going to run this program, I'd end up in all the performers would come out and perform one by one, right? They perform, then I would get initialized to the next one, and that next